Today we're taking a look at 313, solving quadratics with complex solutions. So we looked at operations with complex numbers. So now we're going to talk about actually solving quadratic equations. So the first thing we're going to look at is just how to simplify radicals with complex numbers, because we didn't practice this very much last time. So if I want to take the square root of -4, I can actually break that up into the square root of 4 times the square root of -1, which we learned about in our unit about square roots, or our lesson about square roots. I can rewrite the square root of 4 as just 2, and I can rewrite the square root of -1 as I. So actually, the square root of -4, which usually is just no solution, can't do, can actually be rewritten as 2I. So I just want to show you this mode on your calculator. See how the row I'm pointing to has real or imaginary? I just changed this calculator into complex or imaginary mode, A plus BI, by pressing enter. I just want to show you what happens if I take the square root of -4 on the calculator. It actually is going to tell me the answer is 2I. If I was back in real mode here, when I take the square root of -4, the calculator tells me there's no real answer. So I just think that that's an interesting feature on your calculator. All right, so the square root of -100, I can represent as the square root of 100 times the square root of -1, or just 10I. So I'd like you to pause the video for just a couple seconds and do example 3 and example 4 before I talk about those. 5 through 10 are a little bit different, but try example 3 and 4 right now and pause the video. Okay, so on number 3, you should have gotten 5I, and on number 4, you should have gotten 8I, right? Just taking the square root of the number and then adding I after it. So in 1, 2, 3, and 4, these were all perfect squares, so there's no radical in our answer. The square root of 64 is just 8. So that's an important distinction between a perfect square radical and a non-perfect square. So in example 5, we have to look for a factor of 40 that is a perfect square. So how about 4 times 10 times -1? So there's just one extra step this time, right? We would have done 4 times 10 in the past. Now it's a negative, so we're adding the square root of -1. So our answer would be 2 root 10I. And I want you to make sure that just the 10 is under the square root. So the I is coming after the radical. It's not under the radical. Let's do one more together. So 200 has the factors of 100 times 2 times -1. So our final answer would be 10 root 2I. So I think you should try pausing the video and trying 7, 8, 9, and 10 on your own. And now I'm going to go through the answers to 7, 8, 9, and 10. So on 7, you should have done root 4, root 2, root -1, because that's -8 when you multiply them together. So 2 root 2I is the solution. And 75 would be 25 times 3 times -1. So 5 root 3I. Now, -6 doesn't actually have any factors that are perfect squares. So I'm going to leave that as the square root of 6 and just call it the square root of 6I. And we know that -1 by itself is just I. All right, so now we're going to practice our 3 techniques of solving quadratics. And instead of saying no real solution, we're going to actually solve for the complex roots. So these are the 3 strategies that we talked about during virtual module, other than just factoring. So the first strategy, taking square roots, your first step is to get x squared by itself. So in this problem, I would first have to divide both sides by -4. X squared is -4. I'm taking the square root of both sides of the equation. So I have to remember that I could get two solutions, the positive or negative of this square root, because I took the square root of both sides. And root 4 we said was just plus or minus 2i, right? Because the square root of 4 is just 2, and then I is representing the fact that it was imaginary. Example 2. My first step would be to subtract 20 to the other side, so 2x squared equals negative 24. What would I do to get the x squared by itself? Divide by 2 on both sides. So x squared equals negative 12. Take the square root of both sides. So x equals plus or minus. Now 12 I would have to break down into a perfect square. So how about 4 times 3 times negative 1. So 2 root 3i plus or minus 2 root 3i. All right, so taking square roots, your big objective is to get x squared by itself. And you don't have any x term. So completing the square, see how both of these problems have x terms? I can't just move them to the other side and take the square root anymore. So I need a new strategy. Completing the square. I usually use this if it's not factorable. So my first step is to move that c value to the other side of the equation. So x squared minus 2x equals negative 5. I'm leaving myself this space here to complete the square. I cut this number in half and square the result. So negative 1 squared is 1. And whatever I add to the left side, I add to the right side of the equation. So x squared minus 2x plus 1 equals negative 4. I just created a perfect square trinomial, which means that I can factor this into x minus 1 times x minus 1, right? Because I'm looking for the factors of 1 that add up to negative 2. So x minus 1 squared equals negative 4. I have my perfect square on this side, so now I can take the square root of both sides of the equation. X minus 1 equals plus or minus 2i, because the square root of negative 4 is 2i. My final step would be to add 1 to the other side of the equation, and that's a real number. So I would want to write my answer as x equals positive 1 plus or minus 2i. Or if you prefer, x equals 1 plus 2i or 1 minus 2i would represent the same thing. This is just representing that in one step. So both are correct. Example 4, completing the square. Maybe you want to pause the video and try this problem by yourself before watching the answer. My first step, x squared plus 10x, add 2 to the other side, so you'd have negative 38 on the other side, because I took negative 40 and added 2. What do I add to complete the square? Half of this number is 5, and 5 squared is 25, so I'm going to add 25 to both sides of the equation. This is the perfect square trinomial, x plus 5 times x plus 5, so I can represent that as x plus 5 squared. And negative 38 plus 25 is going to be negative 13. Take the square root of both sides of the equation. X plus 5 by itself is plus or minus the square root of 13i, because 13 doesn't have any perfect square factors. So my final answer is to subtract 5 to the other side. So my final answer would be negative 5 plus or minus the square root of 13i. So kind of a messy answer, but we followed the steps of completing the square. And then our final strategy to review is the quadratic formula. And I'm going to write that down once for us on this page. So the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. We're going to probably get a negative under the radical. And remember, a negative discriminant means there's no real solution. And we're going to go one step further and find a complex solution. So in this problem, a is 1, b is 2, and c is 5. And I'm going to plug that a, b, and c value into the formula. So the opposite of b would be negative 2. plus or minus the square root. B squared is going to be 4 minus 4 times A, which is 1, times C, which is 5. All over 2A, 2 times 1 is just 2 still. Under the radical, I get 4 minus 20, because 4 times 1 times 5 is 20. So I get negative 2 plus or minus the square root of negative 16 divided by 2. And negative 2 divided by 2 is just negative 1. And the square root of negative 16 would just be 4i, and 4i is being divided by 2. So my final answer would be negative 1 plus or minus 2i. So I did the negative 2 divided by 2 and the 4i divided by 2 so that I didn't have to worry about a fraction. So for the last problem here, you might want to pause the video and then check your answer. Little trick here. Oh no, not a trick. I was thinking a negative completing the square. This is just quadratic formula. A is negative 1, B is negative 4, C is negative 10. The opposite of B would be positive 4 this time, plus or minus the square root B squared minus 4 times A is negative 1 times C is negative 10 all over 2A. So negative 2 is my denominator this time. This is 16 minus 40, right? Negative 4 times 1, negative 1 times negative 10 would be negative 40. So what? 16 minus 40 is negative 24. So I've got 4 plus or minus the square root of negative 24 divided by negative 2. 4 divided by negative 2 is negative 2. So let's see, the square root of 24 would be the square root of 4 times the square root of 6 times the square root of negative 1 is 2 root 6i. And I'm dividing 2 root 6i by negative 2. So I would get, I guess the negative doesn't matter because I'm already doing plus or minus, but 2 divided by 2 would be 1 root 6i. So 2 divided by negative 2, 1 or negative 1, but this is plus or minus. So this is pretty challenging. So on your unit test, you're not going to have to do a lot of these types of problems. There might be 1 or 2 questions that asks you to find the solution using complex numbers, but you'll get to pick your strategy. So do you like to take square roots, or do you just like to use the quadratic formula, right? You could always choose the quadratic formula if you want. So you're going to take a little bit of time, and you've got 9 questions on this guided practice, and you might have to choose the same strategy or different strategies. It just says, oh, it actually says by taking the square root. So you don't have to use quadratic formula or completing the square, just finding the square roots, and it says reduce your square roots. So reduce radical form and use your imaginary numbers. Good luck.